Let's talk radians.
My mom's friend me
So are we going to do the circle with one with the radius of 1?
We're going to do a circle with radius r.
Okay. Here's a circle with radius r. Now, you probably are quite familiar with how we measure angles. Yesterday we talked all about what angles are and how we are going to be drawing them and representing them in the Cartesian plane, and how you can have many, many, many angles that look the same that are called coterminal. Just keep adding and subtracting 360 degrees. Now, the definition of a degree is not always useful to us in mathematics because it's defined as 1/360th of a rotation. Whereas lots of times those circles, and we're representing real-life situations, and so a lot of what we are measuring is distances. So having this fraction of a rotation doesn't tell us anything about how much of a distance something has traveled around the outside of the circle. So what we have is a radian, and it's a totally different way of measuring angles, but it's not the same as like a meter versus a foot. Two different ways of measuring length. They're both ways of measuring length. Okay, they're both still just a one-dimensional distance. Where a radian and a degree are not just different ways of measuring an angle, they're completely different ways of going about measuring angles. A degree is a fraction 1/360th of a full rotation, whereas a radian is actually defined in terms of a distance measure, not a fraction of a rotation. So here's what we're going to do. I'm going to take, I took my lanyard apart. I've got a circle here of radius r. It doesn't matter what that radius is. It could be 1 centimeter, 1 foot, 5 miles, 3 light years. Doesn't matter. 3 light year radius. Absolutely. Okay? If I take whatever the length of the radius is, I'm going to mark my string here so that it is the same length as 1 radius. If I then travel the same distance as is the radius around the outside of the circle. So if we go around here, okay, and then let's mark that. Okay?
Let me match it on the computer here. Right there. Perfect, right? So that's also a radius, that's length r as well. Okay? And this arc right here, this is called an arc. What is the length of that arc? R. If you were to take that and straighten it out, it would be r. This angle right here that we've just created is the definition of what 1 radian is. So it should be no surprise why the word radian is such a similar word to radius. Okay? Because that is literally what it means. 1 radian angle corresponds to a distance of 1 radius around the outside of the circle. First thing you should notice is 1 radian is significantly larger than 1 degree. Okay? In fact, can you approximate what 1 radian might be? And I'm going to give you a little a little picture here to help you with that approximation. What if I had a triangle? What if I had a triangle where all 3 sides were r? What would this angle right here measure? 60 degrees. Well, what we have isn't a triangle. That's r, r, and r. It's an arc. It's actually, this pie wedge shape has a special name. It's called a sector. Okay? You can approximate a sector with a triangle, but the reality is, if my arc length here is r, this angle is going to be what compared to 60? It's got to be smaller. So 1 radian is just barely smaller than 60 degrees. Okay? It's close to 60, but it is smaller. I think it might actually be like 56 or something. 57.3. Okay, so right around 57 degrees, one radian. Okay? Now, one of the things I want to do right now is let's continue drawing a bunch of radians. Let's see what 2 radians looks like. I'm going to guess it's a little bit smaller than 120. No? Yeah, go for it. So let's mark a radius again. Let's travel around the outside of this circle another radius in distance. Let's mark that. Okay? Let's maybe travel that distance again. Hey, see you. Okay? So let's mark these. It's kind of hard to do. Okay. So here's another radian. Here's another radian. The first thing you should notice is 3 radians is not 180 degrees. It's just short of 180 degrees. And so one of the things I'm interested in knowing is just how short is it? How large is that angle right there that 3 radians is just short of? I'll say it's right around 14% of a radian. So you've got 1 radian, 2 radians, 3 radians, and then if you want to do a full 180, you've got to go another 0.14 of a radian, approximately. Okay? Let's keep going around this circle. See if maybe we can figure out how many radians are in a full rotation. So let's go another radius. Put that here. Let's start. Okay, there's one. Let's mark another radius here. There's another radian. And something like that. Okay? And so we end up with, let me mark these. Oh, I can't see my first marking. Is it way down here? Yeah. Oh, did I go from the red or the black? I think, did I mess up? Yeah. It should be going from up here. It's kind of hard to do. It's much easier on these big. Yeah, that's not too far. That's not too far up. Say that again? Yeah, right. That's what's interesting. The actual size of the radius of the circle doesn't matter. 1 radian measure always ends up being the same. Okay? Because it all changes proportionally.
So that's why it would be easier to show it radius equals 1.
I think it's easiest to just not even label what the radius is. Okay? So there you have 1, 2, 3, 4, 5, 6, and then a little bit more. Okay, it's close to a quarter of a radian, a little bit larger. It's about 28% of a radian. Okay, so the question becomes, why is it such an arbitrary size? Why is there just this weird 6.28 radians in a full circle? Why is it so arbitrary? Well, a radian measure is a direct correlation to a distance traveled around the outside of a circle, right? In fact, each radius, each R you go around the outside of a circle represents 1 radian inside the circle. So my question to you is, how many R's are there around the circumference of a circle? How many radiuses are there in a full circumference? Well, first of all, what is the circumference of this radius R circle? The circumference of the circle is 2 pi r. Agreed? So my question to you is, how many radius does it take to get around the full circle? 2 pi of them. And each radius around the outside of the circle corresponds to a radian inside the circle. So how many radians are there in a full rotation? 2 pi. Exactly 2 pi. So what this means is 2 pi radians is congruent to 360 degrees. Okay? 2 pi radians
It's the same exact angle measure as 360 degrees. Pretty interesting, yeah? So what you're seeing is 6.28, 3.14 doubled. 1, 2, 3, 4, 5, whoops, 1, 2, 3, 4, 5, 6.28. That's how many radians there are in a complete rotation. Yeah, because clearly the number 2 pi and the number 360 aren't the same. So I don't want to say equal, so I said congruent. Three lines like that means equivalent to or congruent. Make sense? So, yes. Yeah, a radian measure is 1 radian is traveling 1 r, whatever r happens to be, around the outside of the circle.
So that R never changes.
R could change.
But not.
So if your circle gets smaller, what's happening to the radius of the circle? It gets smaller, which means you're traveling a smaller distance around the outside. So if your circle is smaller, you're going to have a smaller radius. So it's going to be a smaller distance around the outside you travel. Your angle is going to end up actually being the same. It all scales proportionally.
The amount of.
So if I wanted to know, what does an angle of 3.7 radians look like? I would travel 3.7 r values around the outside. So here's a distance of r, here's a distance of 2r, here's a distance of 3r, here's a distance of 3.7 r's. So that angle right there would be what 3.7 radians looks like. Does that make sense? Okay. So that's important to think about and understand how the radian measure of an angle has a direct relationship with arc length and circumference. Whereas degree measures have a direct relationship with what fraction you've rotated. Okay, so they're different. They're different uses. Okay? So what are some common measurements? Well, 360 degrees is equal to how many radians? 360 degrees is equal to 2 pi radians. Now the interesting thing is, degrees always have that little circle symbol, right? For radians, we usually don't write a unit at all. So if you just say 5, I'm going to assume you mean 5 radians. If you say 2 with a little circle, that's 2 degrees. Does that make sense? Okay? So we don't really have a unit for radians. Yes?
But wouldn't it be much more comfortable to just express all radians through pi? All radian measures.
You can't express, most angles cannot be expressed as a multiple of pi.
Well, like
if I have an angle that's
multiplying pi by something and dividing.
so for example, somebody give me an angle. What's your favorite angle?
57.
57 degrees.
Okay.
If we want to express 57 degrees in terms of radians, it's not going to be nicer to write that as a multiple of pi radians, right? Only certain angles, very, very few of them actually in reality, can be nicely written in terms of pi. So let's see what Alex is talking about. So let's go back to this. 360 degrees is a famous angle, right? It's 2 pi. Just memorize it. Second nature. 360 degrees is 2 pi. What's another famous angle? Maybe 180. Can you tell me how many radians 180 degrees is? About 3.14 radians. It's exactly pi radians. We are actually going to express lots of our radians in terms of pi. Don't get confused. The pi symbol is not your unit for radians. When you see 2 pi, that is not 2 radians. That is over 6 radians. Always remember that. A lot of students get so used to writing that pi, they almost treat it like it's the unit, kind of like that little circle, and they want to call that 2 radians. That's 2 pi radians. That's over 6 total radians. Pi radians is not 1 radian. That's 3.14 radians. What's another famous angle? 90 degrees. That is pi halves radians. That is just just barely larger than 1.5 radians, right? Pi halves. Pi divided by 2, 1.570796327. That is 90 degrees. So you can see, radian measures have really gross values, right? What's easier, to do a problem calling something 90 or calling it 1.570796327? 90 is so much easier. But what we do instead is we actually do all of our work writing it like that, pi over 2, not 1.57 blah, 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 blah. So we are going to typically do all of our problems using fractions of pi radians. Unless you get something that does not get written nicely as a fraction of pi, like 57 degrees. Or 1, 2, 3, 4, 5, 6, 7. I mean, most angle measures actually don't get written nicely as a fraction of pi. But 180 does, and 90 does. 45 does. What's 45 degrees? Pi fourths radians. What's that? Sure. 22.5 degrees is what? Pi eighths radians. Right? Pi eighths, 22.5 would be pi eighths. 270 would be 3 pi halves radians. How about 30 degrees?
30 degrees.
Well, it's not easy. 30 degrees, here's what I do. Pick one of these. What can I do to 180 to get 30? Then divide that by 6 as well. Pi 6. 30 degrees is pi 6. How about 60 degrees? They'll just double that. What's pi 6 double? Pi thirds. So those are the famous ones you're going to memorize. This, these. Just straight memorize them. 270, absolutely. Okay? You're going to memorize those, and you're going to memorize all of the multiples of them. So 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 340, 330, and then 360. Those are all, you're going to have them all memorized. Okay? That's all I do. All I do is I memorize the first quadrant, quadrant 1. I memorize 30, 45, and 60, and then the rest I just figure out based on that. 345? Let's figure it out. How many radians is 345 degrees? First of all, 60 degrees is pi thirds radians. Okay? Start memorizing those now, because eventually you're going to have to be quick at knowing lots of things about these angles. For example, I'm just going to go ahead and give you a preview of what you're going to have memorized in a couple weeks. We have the unit circle. I'm sure you've all heard of it.
Are you going to have to memorize the sine, cosine, tangent of
all those
pi over
angles?
6, pi over,
Yep.
like the 1/2 and radically.
So you're going to have to memorize all of this. Okay? Right now, all of these weird fractions out here, you don't know what those mean yet. So don't worry about that. But you should know that 0 degrees is 0 radians. 30 degrees is pi 6 radians. 45 degrees is pi fourths radians. 60 degrees is pi thirds radians. Right? 315 degrees is 7 pi fourths radians. So you should at least start to work on making those second nature. If I say, what's 240 degrees? You tell me 4 pi thirds radians. If I say, what's 5 pi 6 radians? You say 150 degrees. Okay? Then we'll start to learn what all these coordinate points, all those weird fractions mean. And then we'll start memorizing those as well. Okay?
And not only do you have to have all this memorized, you have to be able to, in your head, through memorization, also be able to divide these fractions from each other. Or given a division, find what fractions created that, and then find what angle created that. So there's a lot of use to this. So having it memorized is hugely valuable, okay, and useful to you. And that Wikipedia unit circle right there is one of the best I've ever found. So that's a good one to print and post on your bathroom mirror so you see it every morning. So 3 pi halves. So let's just do a couple. How many radians is 60 degrees? Pi thirds, very nice. How many radians is 135 degrees? Three pi fourths. Okay, so how do we figure that one out kind of quickly? Okay. First of all, can you successfully identify where 135 is? 135 is pretty much exactly that angle right there. Right? What's special about the angle 135? What is 135 a multiple of? 45. You need to identify that right away. 135 is a multiple of 45. In fact, 135 is 45 times what? 3. So you take 45, which is pi fourths, and you just multiply by 3 and get 3 pi fourths. That's what I do. I figure out how many pi fourths is this one. Here's pi fourths. Here's 2 pi fourths, because what does the fraction 2 pi fourths simplify down to? Pi halves, that's 90 degrees. And you just count. There's 1, 2, 3. Okay, that is 3 pi fourths. Okay? How about negative 270 degrees? Negative 3 pi halves. Because pi halves is how much? 90. So if you go a negative 90 and do it 3 times, right? That's going to go 1, 2, 3. That's your negative 270, which happens to be coterminal to what? Pi halves, or 90. Okay? What is 67 degrees as a radian? Is it even worth writing as a fraction of pi? No. So give it to me as a decimal instead. How do you even find out what that is? So my question here is, what is our general mindless way of converting degrees to radians, radians to degrees?
Divide 360 by
There's an easier way than that. Remember this. Pi radians equals how many degrees? 180. So what that does for us is that gives us a conversion factor, because essentially, what is pi over 180? 1. And what is 180 over pi? 1. So these fractions are your conversion factors. Think, what do you call it in science? Think dimensional analysis. To convert degrees to radians, you need to cancel away degrees and replace them with radians. Right? So you're going to take the number 67, and you're going to multiply by which of these fractions? Pi over 180. And that's it. Because the 180 is in the denominator, your degrees are going to cancel, and then what's in your numerator, which is pi, which is a radian measure, gets replaced as your new unit. So in your calculator you can do, and I'm guessing it's going to be slightly larger than 1 radian, right? Because 1 radian is 57 degrees. So 67 times pi divided by 180, 1.169. Pi radians over 180 degrees is like having the number 1. That's like multiplying by the fraction 12 inches over 1 foot. What is 12 inches divided by 1 foot? It's kind of like you're not changing the value, you're just changing the unit. Does that make sense? So pi radians over 180 degrees won't change the value, it will change the unit from degrees to radians.
I go for 180.
274 radians?
No,
Whew! That's a big angle there.
degrees.
274 degrees multiplied by pi over 180. Always pi over 180. Doesn't matter where it's at. There are lots of times in trig where you have to be aware of what quadrant your angle's in. Very aware because not everything works perfectly all the time. But for something like this, it works perfectly every time. You don't have to worry about it. Okay? Ooh, how about this? 37 radians. How many degrees is that? So here we multiply by 180 over pi. That's going to be gigantic. That is 2,119.94 degrees. That's massive. How many full rotations is that? A lot? Oh, no. Divide that by 360. Or divide 37 by 2 pi. 5, just short of 6 full rotations, yeah. Now, if you press mode on your calculator, you probably all noticed there's a radian mode and a degree mode in your calculator. Right now, my calculator is in what mode? Radians. So that means if I were to say, hey, what's 2 plus 3? It's going to treat those as radians and give me back 5, essentially, in theory. Now, I can actually, there's an angle menu in your calculator. The second button for the apps. Okay? So if I type a number like 114, if I hit enter now, my calculator is going to treat that as a what? Radian. But if I go to the angle menu and I actually select the degrees symbol, I'm telling my calculator 114 is actually a degree measure. And watch what happens when I hit enter. 1.989. What did it just do? Is it giving me a degree symbol for that number? No. So because my calculator is in radians mode, that must be a radian measure. It just converted degrees to radians just by typing that degree symbol. You don't ever have to change the mode your calculator's in. And I actually think it's a good habit because I don't know if you've experienced this yet, but lots of students miss problems because they have their calculator in the wrong mode. Right. So what I do personally when I take tests, I leave my calculator in radians mode all the time. But if I happen to do a problem that involves degrees, I always type the degree symbol to let my calculator know this is actually a degree. Yeah. In that software I like to use, Mathematica, it does not even have a degrees mode. The software is always in radians mode. You literally have to type the word degree after a number to tell the software that this number is actually a degree measure. Okay. Now your calculator does allow you to switch modes. So if I were to switch this calculator to degrees mode, right? If I type 114, it says 114. Had I typed 114 before, it still would have returned with 114, but it would have been 114 radian. Now, if I type 114 and I type the degree symbol, what's it going to output? It's going to output 114. My calculator is now in degrees mode. Okay? But if I were to type 2, go to the angle menu, but select this R, your calculator has created what it considers a radian symbol. Now it'll give me 114.59, which is a degree measure. Okay? So your calculator can do conversions. You got to know what mode you're in so that you know what symbol to type and so on. Pretty cool? Pretty cool.
Can you give an example?
Like what?
Like, find out what this is, but like, not my together, so I have time to figure it out.
I would like to know what 13 degrees is in the radian. Yeah, go for it. got it yet? They've just done it two different ways.
Oh.
Just multiply by pi, divide by 180. That's all you got to do. To convert 2 radians, multiply by pi, divide by 180. There's a lot of other good stuff in that angle. We will eventually learn some things. Your calculator talks about degrees, minutes, seconds. I typically don't teach it, but then it shows up on like your exam and some homework problems, and students are like, what's degrees, minutes, seconds? So this might be a good time to talk about that. Yeah, let's learn it. Okay. And when it comes to degrees, let's say I have 57.62 degrees. Traditionally, people have actually described fractions of a degree not using decimals, right? Imagine we lived in and that's weird, right? Why wouldn't we just say 57.62 degrees? Well, think about this. What time is it right now? Right now it's 12:26. If you think about it, that makes no sense. Instead, it should be 12.43 repeating o'clock. Why don't we use decimals for time? Why do we have this concept of hours, minutes, seconds? Right? 26 minutes is just short of half of an hour. So really, it's just under 12.5 o'clock. 12.43. Why do we use minutes? What is this? And there's 60 minutes in an hour. It makes no sense to me. Why don't we use decimals? Well, degrees are actually measured the same way. They don't use decimals. Guess what they use? Minutes and seconds. So what is 57.62 degrees? It's 57 degrees. It's 57 degrees. Then let's take that decimal part, 0.62. How many minutes is that? Well, multiply it by 60. So it's 57 degrees, 37 minutes, which we just used a little tick, prime, apostrophe. Then take that decimal part, 0.2, and multiply it by 60 in 12 seconds, which is a double, like a quotation. So 57.62 degrees is called 57 degrees, 37 minutes, of which, how many minutes is exactly half of a degree? 30 minutes. So 37 minutes, that should be larger than 1/2. 0.6, yeah, that makes sense. And then 12 minutes, or 12 seconds, makes 57.62 degrees. Right. So, yeah. Clocks are circular. You think it has something to do with that? I don't know. I have to look it up. It makes sense, right? I'd imagine that's how it is. But here's the interesting thing. Isn't that how longitudes and latitudes are measured? In degrees, minutes, seconds? Yeah. They're not measured in decimals. Yeah, I posted it first period this morning. Now, real quick, this homework is not for tonight. Not for tonight. It's for tomorrow night. Do it over the weekend. It'll be due on Monday, but not tonight. Your homework tonight is to what? Study. Study.